Alright, so here we have 9.1 exercise. In here, in number 2, you can see that a data table is given to you. That is, each of this is given in a data arrangement. So the first data is given, that is 3 by 45. Acha, it is written over here that it is direct variation. So whenever direct variation will happen, I told you the formula, that is the ratio of two variable will be always constant. That means the ratio of variable will have always same value. So the first values are 3 by 45 as given over there. So you can see that from there you will get 1 by 15. Yes. So finally you got the value of x by y, which is 1 by 15. And it is always remain constant, always remain same. Now coming to the next value. In here, the value of x is given. You have to find the value of y. So, in the place of x, you have to put the value of x, which is given as 5, and value of y is missing. So, all we need to find the value of y. So, if we solve this one, we will get that 15y equal to 15 into 5. So, it will be 75. So finally we got when x is 5, then y is 75. Let me do another one for you. Next one, 90, the value is given for y. So this time we're gonna need the value of y as 90 and we have to find the value of x. So put the value over there, 1 by 15 as it is always constant. So find the value of x. That is 90 and this is 15. So finally you can see that it will cut by 6 and the value of x will be 6. So in the place of this you can put it will be 6, the value of x. So I told you the first or the master formula, that is x by y ratio will be always remain constant. If you know this one, you can find any given value over there. Either x is given, y is missing, you have to find y. Either y will be given, x is missing, you have to find x on that time. Moving to number 6. In number 6, if a car travels 67.5 kilometers, that is the first distance, I will write that. That is 67.5 kilometer. Okay, in 4.5 liter. Okay, so the oil consumption is 4.5 liter. Achha. So we know that if we travel more distance, more oil will consume. If we travel less distance, the oil consumption will be also less. So that is no doubt direct variation. So we can actually apply over here our formula. I'm writing this distance as capital D and this amount of oil as capital A. So the two variables are given to me, that is D and A. How we can write that one? That first of all I am writing as A by D. So what is that? The value should be A, which is 4.5, and the D value, which is 67.5. All right. So we got the ratio of A by D, which is 4.5 by 67.5. All right. Now what is given over there? If we travel 26 with 26.4 liter of petrol, then how much kilometer we will travel? So this time the value of petrol is given. That means A is given. Let me arrange it a little bit. So D equal to, I'm just rearranging by cross multiplication. So D equal to 67.5 divided by 4.5 into A, where A value is right now given, which is 26.4. So I put that over there. Finally, if you solve this one, you will get 396 kilometer. So you will have the traveling distance, which is your answer. I hope you got that idea. Now moving to the next sum. Number 10. Anita has to drive from village A to village B. She measures that the distance is 3.5 centimeter between these villages on the map. What is the actual distance between the villages if the map scale 1 centimeter equal to 20 kilometer? Okay. So that is very much simple. You can also use the unitary method that 1 centimeter is given as 20 kilometer. Then how much is the distance given? 3.5 centimeter. So 3.5 centimeter, that is as 20 into 3.5. So the calculation is also easier. Just break that decimal into 35 by 10, cut that with 0, and you will get 70 kilometer as your answer. So is that thing in direct variation or not? Yes, it is in direct variation. If you want to do it in the form of direct variation, then just write it like this, that 20 by 1, that should be equal to x by 3.5. So you have to find the value of x from here, which will be nothing but 70 kilometer. If you want to do it in direct variation form, I gave you both strategy over here, and now it is up to you that which one you will follow. Alright, so after completing this video, remember that you have to do this number 3, number 8, and number 12, and you have to submit this in PDF form. All right. So we have exercise 9.2. This exercise is all about inverse proportion or inverse variation. And I told you that the master formula of inverse proportion or inverse variation is the product of the given variable should be constant. First of all, you can see over here number 3, which is under the condition that the temperature remain constant. The volume of gas is inversely proportional to the pressure. If the volume of gas is 630 cubic centimeter at a pressure 360 millimeter of mercury. So first thing is that V is given, that is 630 cc cubic centimeter. Okay. And the pressure is given as 360 millimeter of mercury. We write it as mmHg. Hg is the mercury sign. We know that. And next part, that is, this one is P1 and V1 given to you. Now coming to the next sentence, which is then what will be the pressure of the gas if the volume become 720 cubic centimeters. So V2, that is the next volume is given, which is 720 cc, and all you have to find the pressure, what will be the final pressure. So how we know that the relation between P and V? It is told over there that they are in inverse proportion or inverse variation. And I told you that for inverse variation, the product of two variables are always constant. So PV is constant. That means P1 V1 should be equal to P2 V2 because the product will always constant, as I told. So let's do it over here with the values. So finally, if you put all these values over here, that is 360 millimeter Hg P1 into 630 V1, and I'm also sending that V2 in here in the denominator, so that is 720, that is equal to P2, that is we need. So finally, after calculation, you will find that P2 will be 315 millimeter Hg. So that is the pressure of your and also your answer. Now moving to number 6. In this number 6, you can see that the first work, that is, it takes 8 days for a man, 12 men to construct a wall. Okay. How many days or how many men should be put on the job if we need to construct this wall in 6 days? We know that if we increase the manpower, that what days will decreases. So it is clearly the inverse variation. So we will write it like this: man, that is M1, which is called 12 men are over here, and days, which is D1, that is 8 days. That is our first conditions as given. Now, in the second condition, what is given? That is how many men is required. So M2, that is our required. And 6 days is given. That is D2 equal to 6 days. All we know that the product will be always equal or always constant. So we will do it like that. M1 D1 equal to M2 D2. And what we need over here, that is M2. So we have to rearrange the equation in the form of M2 first by cross multiplication, and finally we will get M1 D1 by D2. So this is totally completed right now. We just have to put the values over here. That is 12 into 8 divided by 6, and very much clear that it will be 16 men. So finally you got the value of men that need to complete that total work in 6 days, which is 16. Lastly, coming for number 11, what is given? A fort is provided with food for 80 soldiers to last for 60 days. Find how long would the food last if 20 additional soldiers join after 15 days. Okay, that is a quite issue over here. First of all, see that the soldiers are joining after 50 days, and how much? 20 more. So right now, after 15 days, you will get total 100 soldiers over there. So the first value should be that soldiers is 1, which is 80. Acha. So for 80 soldiers, 60 minus 15, which is 45 days. For 80 soldiers, the 45 days will be different. So all you have to complete, that is for 45 days. Cause after 15 days the additional soldiers are joining. So all you have to calculate after 15 days. So how many days left? 45 days. So days are D1 equal to, I will take as 60 minus 15, which is 45. Okay. Final soldiers are 100. We know that 80 are already present and 20 more has come. So totally you are getting 100. And we have to find that how many days the food will last. So let's see. We got the values. All we have to do, find the D2. And as we know, this is totally inverse proportion. So we can say the product will be always constant. So S1 D1 equal to S2 D2. Acha. So what we have to find, that is D2 equal to S1 D1 by S2, where we should put the values over here. That is 80 into 45 divided by 100. And finally, if you calculate this one, 0, 0, then it will be 4, it will be 5, and it will be 9. So it will be 36 days. So finally, the food will last for 36 days. So that is your answer. I hope you get that idea of direct and inverse proportion. Right now is time for the homework. I told you 3 homework earlier. I'm adding another 3 over here. That is number 4 of 9.2 exercise, number 10, and number 12. These three you have to submit including with 9.1 exercise in PDF form within class time. So thank you all. We will meet in the next video.